Myself, Dr.K Viswanath Allamraju, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today we are going to solve, or in this session we are going to solve a problem by using instantaneous center method and find out the velocities, both linear and angular velocities of a mechanism, of a given mechanism. The given mechanism here it is having how many links? First you have to find out the number of links in this mechanism. It is a wrapping machine. So the mechanism of a wrapping machine has the following dimensions, such as O1A point. There are various points are there: O1, A, B, C, D, O2, E and O3. The length of this mechanism O1A, that is 100 millimeters, AC equal to 700 millimeters and BC equal to 200 millimeters. AC is 700, BC 200 millimeters. From link O3 to C, O3C is 200 millimeters. O2E, from O2E, that is 400 millimeters. O2D, 200 millimeters. And finally, the link between BD is 150 millimeters. So this is the mechanism of a wrapping machine. Now what to be found? We have to find out the velocity of the point E of the bell crank lever. The bell crank lever here it is DO2E. This portion is the bell crank lever. This part is the bell crank lever. By instantaneous center method. But the input, what is the input are given? The input given here it is the crank O1A is rotating with a uniform speed of, directly given, that is in radians per second, 100 radians per second. This O1A is rotating with 100 radians per second. And we have to find out the velocity of the point E. Velocity of the point E. What is the functioning of this bell crank lever? What is the functioning of the mechanism? When it crank OA is rotating, this link AB or AC is having the oscillatory motion. This bell crank lever is connected to the link AC with the help of point B to D, the link. Then it gives motion. Okay, when it is, and it is fixed at O2. That's why this is the mechanism of a wrapping machine. How to find out? First of all, how to find out the velocity of the point E of a bell crank lever? They did not ask you velocity of the point D or velocity of the point B or point C and point A. It is asked that what is the velocity of the point D, point E? Which velocity? Is this linear velocity or angular velocity? Yes, we have to find out the linear velocity. Whatever velocity may be, you have to find out by using this I-center method. So before going to start the problem, we have to find out the number of links. of a mechanism. The number of links, let me begin. O1 is the link 1, fixed link. O2 is the fixed link. O3 is also a fixed link. O1A is link number 2. ABBC is the B is the only connection. What is the relation? This what? Link 3. And it is link 4. And okay, and find out various links, and link 5 and also 6. Link 4, it is link 5 and it is link 6. It is a 6-bar mechanism or 6-link mechanism. So the number of links, as I shown you, this is link 1 and it is link 2 and it is link 3. Okay, link 4, link 5 and 6. Assume that here why it is the relation between B and C, there is no relative motion. This point B is the point on the link AC. It is a supporting. There is no relative motion between the links AB and BC. This AC is considered, ABC is considered as only one link. So the number of links are 6. So then what to do? The number of eye centers, n equal to n into n minus 1 by 2. What is the n is here? 6. 6 into 6 minus 1 by 2. Subtracting 6 minus 1, that is 6 times 5 by 2. That is 30 by 2 equal to 15. The number of eye centers are 15. So these eye centers, we can list all the eye centers, 15 eye centers. We can all the types of eye centers with the help of the combinations of links versus type of eye center table. The links are 1, 2, 3, 4, 5, 6. Combinations 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 3, 2, 4, 2, 5, 2, 6, 3, 4, 3, 5, 3, 6, 4, 5, 4, 6 and 5, 6. So in this problem, locating all the eye centers is not asked. So no need to locate all the eye centers. So which eye center we have to locate? Now, based on the objective is mentioned here that we have to find the velocity of the point E. Velocity of the point E of the bell crank lever by eye center method, instantaneous center method. We have to find the velocity of the point E of the bell crank lever by eye center method. Okay. Now, these are the combinations and another diagram. Here, what is the eye center here? Now again, the combinations are, these are the combinations. By using circular diagram, in the circle diagram, locate your links 1, 2, 3, 4, 5 and 6. Join all these. Based on the combinations, we have to go for it. As we have studied in the previous session, in the previous class, 15 eye centers can be located. But now, some of the eye centers which are located here, how many eye centers are located in this diagram is called 9 eye centers we have located. That is the requirement in order to calculate the velocity of the point E. Okay, now, before going to start all the things, how to locate the eye center. In order to locate the eye center, in the answer script, you have to redraw the configuration diagram. In order to redraw the configuration, we have to redraw the configuration diagram. After drawing the configuration diagram, again, how to redraw the configuration diagram? By the practice, you can redraw any diagram. You have to know it, how to. Okay? Based on the practice of drawing different various configuration diagrams, you can. If you want to know how to redraw the configuration diagram, let us begin. Based on this data, I'm going to start how to redraw this configuration diagram. Yes, take any point, take any line, any horizontal line. First, you have to mark reference lines. The reference lines are here. There are two reference lines are there, two horizontal lines. You draw one horizontal line. Above that, another horizontal line at a distance of 200 millimeters. I am considering 1:1 scale here in order to make you to understand. Based on that, you can reduce the scale also. Reduction scales also can be taken. You can take it. You can take reduction scale, that is 1:10 or 1:5 scale. I am considering here 1:1 scale. That is full scale I am taking. Now draw another horizontal line, that is 200 millimeter. This is the first step. It is second step. After that, how to start? You draw a vertical lines. This is the vertical line, point 1. From this vertical line, step 3. At a distance of 300 millimeter, another vertical line. Point, reference line. From this line to fixed point O22, again another point you take it, or reference vertical line you consider it at a distance of 400 millimeters. Now we know these lines. Now start, beginning with this. Point O1, mark this point O1. Take a length with the help of protractor. Draw a line, inclined line, that is 60 degree. Mark what is the length O1 to A. O1A length is how much? 100 millimeters. With the help of compass, give a arc. Mark a arc. That OA, point A, OA. Then the combinations will begin here. Now there is O2 is there. O2 and it is O3. Now O2, at this O2, okay, the inclination of this one we don't know. What are the inclinations? This inclination is required. Now how to get that inclination? Okay, it is connected to point B. How to get that point B? That point B is located on point A. How to get point A? We know the point A, but we want point C. That point C is the combination from A to C length and O3C combination. What is that AC? That AC was given 700 millimeter. From A to point A to C, draw a arc. Mark a arc. We know O3 point location. O3C distance we know. That is 200 millimeters. Thus 200 millimeters, draw another arc. Mark it as point C. Join point A to C and O3C. That is the next step. Fourth point, this is the fifth and it is sixth. Okay, don't get confused the number of links and steps. We know link. Now we know that ABC we know. AC to O3. Now, next which point you have to mark it? Point B. What is the distance BC link? That BC is 200 millimeters. B to C, O3C, A3C, yes, AC. What is that BC? 200 millimeters. From C to B, locate the point B. Now we locate the point B. Now we have to go locate point D. How to locate point D? This D is the intersection of O2D and BD. What is the O2D distance? We know here O2D is 200 millimeters. With the help of compass, by using compass, draw an arc. And BD we know. Where is the point BD? 150 millimeters. Point B to D, another arc. Now O to D join and BD join. Now this O to E is 90 degree to O to D. But what is the length of O to E? That O to E is 400 millimeters. Now this is O to E. Draw a perpendicular line to O to D and mark with a length of O to E 400 millimeters and locate point E. Now this is the free body diagram, or this is called space diagram or configuration diagram. We have to redraw in your answer script before going to locate eye centers or solving or doing velocity analysis by eye center method. Alright. After drawing this, then we have to mark eye centers. Combination of eye centers. Link 1 to another one eye center and 2 and 3, 2, 3. Okay. And 3, 4, 3, 5 various eye centers. 3, 4. This is link 3, 4. Eye center 3, 4. 3, 5. 1, 5. 1, 4. 5, 6. 1, 6. Let me note down all the eye centers from our eye center table. Okay. We'll mark it in this eye center table. One, 2, 1, 3, 1, 4, 1, 5, 1, 6. 2, 3, 2, 4, 2, 5, 2, 6. 3, 4, 3, 5, 3, 6. 4, 5, 4, 6. And 5, 6. What are the eye centers we are located here? Now 1, 2 eye center is located. 1 and 2. 2, 3. 2, 3 and 3, 4, 3, 5. 3, 4, 3, 5. 3, 4, 3, 5. Next 1, 6, 1, 5. 5, 6. Next one, what we have located is 1, 3 and 1, 4. Anything left over here? So total how many eye centers are there? 5 plus 4. 9 eye centers are located here. So why this combination 1, 3 is mixed all the things? 1, 3. Where I 1, 3. This 1, 3 is 8. 1, 3 is a combination of 1, 2 and 2, 3. 1, 2, 2, 3. And 1, 3 is also, it comes under 1, 4 and 2, 4. 1, 4 and 3, 4. So 1, 2, 2, 3. This is 1, 2 and it is 2, 3. You extend a line 1, 2, 2, 3. Another extension is that 1, 4, 3, 4. Where is 1, 4 line? Here it is 1, 4 line. Where is 3, 4 line? Here it is 3, 4 line. You extend a line towards the intersection of another straight line. Otherwise, why only downwards line? Why not upwards line? Because our one line is downwards, so you have to go for it. If you want to draw, you draw upward. What will happen? Where is the intersection? There is no intersection. We have to go towards cooperating to get the objective of 1, 3. So if you draw upwards lines, both the directions, then where is the intersection? Unless and until towards, if you draw downwards, intersection is there. So we are drawing towards downwards line. This eye center is 1, 3. That is the combinations. Alright. In that manner, we can locate all the eye centers. After locating the eye centers, okay, next, which eye center we want to locate? 1 and 6. Directly we can locate I1, 6. Next, neither permanent nor fixed eye center. This 1, 5 is there. How to locate that eye center 1, 5? How to locate the eye center 1, 5? How to locate eye center 1, 5? We have to join 1 and 5 link. We have to join 1 and 5 link. Where is 1? This is the 5. This is 1 link 1 and it is 5. Join. But this 1, 5, we need triangle combination. What is the triangle combination? 3 and like this is one triangle. Another triangle is this one, another triangle. That means this 1, 5 is eye center 1, 5 comes from the combination of 1, 3, 3, 5 okay, and another combination is 1, 6 and 5, 6. You can make it as here 1, 3, 3, 5 1, 6, 5, 6. Then from these intersections, what will happen? What will happen? 1, 5 comes. Where is 1, 3 and 3, 5? We have to know it. 1, 3, 3, 5. 1, 3, 3, 5. This 1, 3, 3, 5. Where is 1, 3, 3, 5? This is 1, 3. And 3, 5 is here. Join 1, 3, 3, 5 line. Join more. Next one 1, 6, 5, 6. This is 1, 6. And where is 5, 6? 5 and 6 is here. So join 1, 6, 5, 6. This intersection is 1, 5. Locating eye center 1, 5. Okay. Thus we have to mark all the eye centers. Okay. Any eye center is left over here. If you want to locate, which is 5, 6. Shall we find out 5, 6? Just before we calculated, I think so. 5 link 5 versus 6. 5, 6. Yes, 5, 6 already there. Okay. Thus combinations 1, 5 and 5, 6. Here it is only 5, 6. So we can locate other eye centers also by using this method. Now, how to find out the point on the link? How to find out the link? Yes. After drawing this configuration diagram and locating all eye centers, we have to measure the distances from eye centers to the particular points. We measured, this is what we calculate, we observed that I13A, that is I13A, I132 point A, that combination is 0.91 meters, 910 meters. I13B is 820 meters, that is 0.82 meters. I15B, that is 130 millimeter, that is 0.13 meter. I15D, I15D, where is I15? This is I15 and it is the point D. That distance is very small. We got it as 50 millimeter, that is 50.05 meters. And I16 to D, this distance, that is 200 millimeters. Okay, this was given already in the problem. Next, I16E, from I16 to point E, that is 400 millimeters, 0.4 meters. Now, we have to find out the velocity of the point E on a bell crank lever. The velocity of the point and bell crank lever is connected to point O2, that is 6 link and also D. That relation you have to find out. That combination is that VA by, in order to achieve that, VA to VB, that is VA by I13, A equal to VB by I13B. What is the VA distance? What is the VA, velocity of the A? That was given, we calculated, that is 10 radians per second, I think so. Yes, 10 radians per second. That is VA by VB equal to VA by I13A times I13B. VA 10 by I13A. What is I13A? 0.91 meters times I13B, 0.82 meters. That is 9.01 meters per second. Next, VB by B is connected to D because we want E. That E we cannot approach directly. This point E comes from, we have to connect point E to A combination. This point E to A, we cannot directly, we don't have correlation directly. So how to get it? E is connected to O2, O2 is connected to D, D is connected to B, B is connected to A. So A value is given here. When A value no, then A is connected to B, that means B value has to be found out. Then has to be found. After B is connecting, B comes to D, then D comes to E. That means in that inbuilt velocity of the point E consists of velocity point B, velocity of point D. Then only we can find out. Now we found velocity of the point B. That velocity of point B, VB equal to 9.01 meters per second. Then B is connected to where? That B is connected to D. Then we need the relation B and D. That BD is the link 5. What is the common eye center? BD link, that is I15. That VB by I15, B equal to VD by I15D. Then VD comes. That VD equal to VB by I15B times I15D. Then VB by I15B. What is the VB value? Just now we've calculated 9.01 meter per second by I15B, that is 0.13. That is 0.13 meter. I15D 0.05. Then the value is calculated 3.46 meter per second. Now, how to approach? D is connected to E. D through bell crank lever. D is on the bell crank lever. Now D and E relationship. What the relation DE combination is? 1,6. So I center, common I center. So omega, that is VD by I16D equal to VE by I16E. Then VE equal to, what is that? VD by I16ED, that is V times I16E. VD we know, that is 3.46, already calculated, meter per second. Then VD by I16D. What is I16D? 0.2 meters. And I16E, 0.4 meters. Substitute over here. Finally, VE can be calculated. So, velocity of the point E. It may be thinking that is only single objective. No. This objective is inbuilt of 3 more objectives. That is point D and point E, point D, point B, point D, and finally we'll approach to point E. This is the manner, in this manner we have to calculate the given objective. Okay. Now, how we have, one more thing. Okay. This is the, in this manner, this is called wrapping machine mechanism. So, we did not locate all the eye centers in this problem. because it is not asked in the problem, because the objective in this problem is that only find the velocity of the point E of the bell crank lever by instantaneous center method. Whenever it is asked only velocity, means it comes under linear velocity. It is not angular velocity. Whereas for angular velocities of the points will be mentioned directly. Find out the angular velocity of the links. Okay. So very, very important problem. Now point E, what we understood in this, the velocity of point A is 10 radians per second, 10 meters per second, sorry. And velocity of the point B is, the velocity of the point B is 9.01 meter per second. Velocity of the point D is 3.46 meter per second. And velocity of the point E is 6.92 meter per second. So the input value, that is 10 meters per second. What the value given here? Let me check. Yes, they have given 100 radians. Yes, that is 10 meters per second. Now VA is greater than all the values. The input value VA is more and output 6.92 per 6.92. That's 6.92 meter per second. So the variation is, it is about the difference 69, about what is the percentage, it comes under around 60%. Okay, 0.6, we get 69.2% variation. Okay, that is the performance. So that much reduced between intermediate links. Why it is reduced? Point E is, the linear velocity of the point E is 6.92 meter per second. It is in linear, even though the linear velocity is VE 6.92 meter per second, when the linear velocity of the crank, that is point A, is 10 meter per second. Okay, thus we can find out, or we can calculate the various points, or the linear velocities of the various points of a mechanism. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.